In the lessons that follow, we'll take a look at rendering a grass field by using Cinema 4D's hair module. In this part, we'll lay down the foundations by setting up the hair generator. With the landscape object selected, navigate to Simulate, Hair Objects, Add Hair. Reduce the guides down to 2000, set segments to 6 and take the length down to 15. Change the root to polygon area, open up editing and click the regrow button. Switch to the hairs tab and take segments down to 6. Open up growth and on the density load a Cinema 4D noise shader. Change the type to Luca and increase the global scale. Switch to Dynamics, scroll down to Advanced, enable Custom and set segments to 3. With the hair object selected, navigate to Simulate, Particles and apply a turbulence modifier. Set both strength and scale to 25. Select the hair object, switch to the Cache tab, pause the IPR and calculate the simulation. Once done, disable the turbulence modifier, move to the end of the timeline, switch to hairs, open up cloning, set clone to 4, scale to 75 and variation to 25%. Finally, change the count to 100,000 and unpause the IPR to preview the final effect. Next, we'll fine-tune the geometrical properties of individual hair strands by using the parameters in the native hair material. It is worth mentioning that the effect of channels such as color, backlit color, specular, and transparency will not be registered by the render engine. So to avoid confusion, these can be safely switched off. Let's start with thickness. Set the root and the tip to 0.2 and increase the variation to 1. Change the spline curve to somewhat represent the profile of a single blade of grass. Enable length and scale and change their variation parameter to 75%. Enable frizz, kink and clump. Reduce the frizz down to 25 and kink to 5%. Finally, unpause the IPR to preview the result. In this part, we'll explore shading the grass field. For this purpose, I have applied a material which has the dedicated hair shader already connected to the beauty port. Let's take a look at the most relevant parameters. Diffuse allows us to define colors for the root and tip of individual hairs. Indirect diffuse controls the influence global illumination has on the hair shader. In order to keep the output physically plausible, it is recommended to stay in the 0 to 1 range. Caching the diffuse could speed up render times, especially in scenes containing many lights. Additionally, the hair shader allows us to layer 2 specular channels. We have the familiar glossiness, weight, color, and rotation parameters. Transmission lets light shine through hair before hitting the camera. This feature is especially useful when doing rim lighting, for example. Unfortunately, this parameter will not be useful in the current setup, so we'll leave it disabled. Next we have opacity, which is used to reduce the visibility of hair. Finally, the parameters under the UV tab allow us to export texture coordinates from the surface mesh. This is useful if you want to map a texture across the surface using both the root and tip colors. In the next part, we'll use this feature to add additional color and luminance variation to the grass field. Next, we'll create a shading network that will be used to add color and luminance variation to our grass field. For the time being, I have disabled the hair object. We'll use the landscape as a simple placeholder, which will help us evaluate the mapping and distribution of values in the shader we are about to build. As you can see, I have already applied an empty material to the landscape object. Let's start with a simple noise. Hold down Ctrl or Command and drag to make a copy. Change distortion and scale to a value of 2. Let's bring the noise shaders together by using a multiply node. To fine-tune the values coming out of multiply, I will use a color correct. Change the contrast to 1.5. Next, create ramp RGB and add an additional color node at 50%. Use the output of color correct to drive the input parameter. Create a flat node and change the color to green. Use that to feed color 2. Create a color correct, channel the flat node in, and use that to drive color 1. Select color correct, change the hue shift to 0.1, increase the saturation to 1.25 and reduce the exposure to -1. Create another color correct, channel the flat in, and use that to drive color 3. Change the hue shift to -0.1, reduce the saturation to 0.75 and increase the exposure to 1. Create another noise shader and add a distortion of 1. Change the scale to 2 and create a range mapper. Channel the noise in and change the output min to 0.85. Create another multiply. Use the range as input 1 and the output of ramp RGB as input 2. Connect the multiply to the beauty port. With that, the variation map is complete. In the last part, we'll bring it all together in order to finalize the look of the grass field. Finally, we'll polish the look of the grass field by using the shader created in the previous lesson. As we already said, adding color and luminance variation will be based on the parameters under the UV channel. The first thing we need to do is apply a parameters tag to the hair object. navigate to the bottom and enable Export UVs. With that out of the way, select the hair shader and under UV, type uparam coord in the first field and vparam coord in the second. Now the grass will be shaded with respect to the UV map of the landscape object. Next, drag the variation shader into the network editor of the hair material. Use it to drive both the root and tip color parameters. Create color correct. Channel the variation shader in. Reduce the saturation down to 0.25. Increase the exposure to 1. And use that to drive the specular color. As you can see in the IPR, now we have a far more interesting field where patches of grass vary in hue, saturation and brightness. Let's change the camera angle to something a bit more dramatic, and we'll call this the final image.